Day 706 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again. Another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 3655 XOR after range multiplication queries 2. The difficulty level is hard, but don't worry because you already know we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, hype, subscribe, comment, and share. And if you need any new Apple AirPods, go ahead and check out that link in the description so you can get you some. Now let's see what the question says. You are given an integer array nums of length n and a 2D integer array queries of size q, where queries of I is equal to li, ri, ki, and vi. For each query, you must apply the following operations in order. Set idx to li. While idx is less than or equal to ri, update nums of idx equal to nums of idx times vi mod 10 to the 9th power plus 7 and set idx plus equal to ki. Return the bitwise XOR of all elements in nums after processing all queries. All right, y'all. So if you've been following along with this channel, you know we did the first version of this problem yesterday. So now that we understand the question, let's get into these examples. But before we get into these examples, I want to show y'all how the XOR operator works. And the question is pretty much the same as yesterday. The principles are the same. Only thing different is these constraints down here. These constraints make it a little bit more difficult. But before we get into example one, or matter of fact, let's get into example one. Before we get into an example one, let's just go over how the XOR operator actually works, right? So the XOR operator works if it's the same bit, it's going to be 0, different bits will be 1. So let me show you what I mean by that. Say we're going to do 1, which 1, the number 1 in decimal is equal to 0, 0, 0, 1 in binary. And then we could just do, let's do 1 and 8. So 8 in binary is equal to 1, 0, 0, 0. Boom. So let's compare these two. So if we compare these two, so let me just, so if we compare these two, we can compare them right here. Boom. So once again, let me just write this so you can see. Same bits equals 0. Different bits equals 1. So let me show you what I mean by that. When we're comparing 0 and 1, that's when we're comparing like this, 0 and 1, that's a different bit. So we'll come over here and then we're going to put a 1. 0, 0, that's the same bit, so that's going to be a 0. Boom. 0, 0, that's the same, so that's a 0. 1, 0, those are different. 1 and 0 are different, so that's going to be a 1 because they're different bits. So when we compare 1 and 8, doing the XOR operator, this would be 9. This right here, so we can just say 9. Boom. Hold on. Boom. So that's just how that, sorry y'all, I don't know what's going on. Boom. That's just how that works. I just wanted to show y'all how that works before we go on, because that's what we're going to need to know as we continue into this problem. So now that we understand the question, let's get into the fun part. For example 1, we have our input nums equals an array of integers 1, 1, 1. Queries equals a 2D array of integers, or with queries. First query is 0, 2, 1, 4. That's the only query in this example. So and the output is 4. So let's look at the explanation so we can see how they got this output from this input. So a single query 0, 2, 1, 4 multiplies every element from index 0 to 2. So let's break that down one step further. Boom. Let me go ahead and copy and paste this query over here so y'all can see what is going on. So boom, we have this. Then we have nums. We can bring nums over here too. Boom. So this, let's say nums query. Boom. So let's come back up here and look at what operations we must apply. So this is L1, right? Boom. This right here, R1. Boom. This right here, K1. Boom. And this right here is V1, or excuse me, not V1, VI, not L1, LI. So let's just come right, let me just write that out for y'all too. LI is equal to index 1. RI is equal to, sorry y'all, RI is equal to index 2 of queries. Boom. KI equals index, sorry y'all, index 3 of query. Let's put that of query 2 so nobody gets confused. And finally, VI equals index 4 of query. Boom. So, hold on one moment, y'all. Boom. So, this is what we're working with, right? So, let's go through the operation. So, first, we're going to set IDX to LI. So, in this case, index, sorry, y'all, doing it wrong. Index 0, index 1, index 2, sorry, index 2, and index 3. It's 0 index, y'all, not 1 index. Sorry about that. So, boom, at index 0, LI is 0, right? So that means we're going to start at index 0. Boom. RI, right? Then it says, so we're going to set IDX to LI. LI is 0, so we're going to set our index to 0. Boom. Then it says while IDX is less, while index, sorry y'all, I'm going to say index instead of IDX so you don't get confused. So we're going to set the index to LI, did that, boom. Now it says while the index is less than RI. So in this case, RI, index 1, boom. So RI is 2. So this is our range, index 0 through index 2. That's the range, right? Starting from here to here, LI to RI. That's our range, index 0 to index 2. Boom. Now, while the index is less than index 2, right? That's what this is right here. We're going to update num's index by multiplying num's index by VI. So this is VI right here. So we are going to, right now we're at index 0. We're going to multiply, let's bring it down here so y'all can see. Right now we're at index 0, and we are going to multiply index 0 by VI. So in this case, VI is 4. After that multiplication, we can put a 4 right here. Boom. Then we're going to increment IDX by KI. So IDX plus index, we're going to increment the index by KI. So index plus equals KI. In this case, KI is 1. So index plus 1, 0 plus 1 is index 1, right? So now we're at index 1. Same thing. Now that we're at index 1, we're going to go through, we're going to keep looping while index is less than RI, and RI is 2. So index 1 is still less than index 2, so we're going to keep looping. We're going to keep going, and we're going to perform this operation again. So now we're at this index. We multiply this index by VI. VI is 4, boom, so we put the 4, boom. Then, once again, we come down here. We increment IDX by 1 because KI is 1. So now we're going from index 1 to index 2. Same thing. We're still in this while loop, right? Because it's while index is less than or equal to RI. RI is 2. So right now our index is equal to RI. Boom. But same thing. Now we got to do this again. Operation. Boom. So 1 times 4. 4. Boom. So we put the 4. Boom. Then we're done, right? Because once index gets equal to less than, or once index equals RI, we could stop, right? So we're at index 2. That's what RI is. So we can stop, even though that's the whole array anyway. But we're not done yet, right? We have this, but we're not done yet. It says return the bitwise XOR of all elements in nums after processing all queries. So this is what nums looks like after we have processed all the queries, right? So now it says right here, the array changes from 111 to 444. Boom. That's where we're at right here. Boom. We have the 444, but we still need the XOR of all elements, right? So 4 in binary is going to be 0, 1, 0, 0. Boom. So we need to XOR these. So that's this 4. Now we got to do this 4. So we could just put another 0, 1, 0, 0. Boom. So when we XOR these, same bits, remember. Oh, I deleted it, but remember. Same bits equals 0, different bits equals 1. Let me just write that again. I don't know why I deleted it. Boom. Okay, so same bits equals 0, different bits equals 1. So, boom, same 0, 0, that's the same bit, so we put a 0. Boom. 1, 1, same bit, so we put a 0. 0, 0, same bit, so we put a 0. 0, 0, same bit, so we put a 0. Boom. But we're not done yet because we still have another 4. So now we have to put the we have to compare this 4, right? These two are just these two 4s, but there's still another 4 we have to compare. So once again, we'll come underneath that. We're gonna say 0, 1, 0, 0. Then after that, we'll say 0. That's gonna be a 0. Boom. Oh, sorry, y'all. Hold on. Let's do this because we're comparing. So once again, 0, 0, same bit, put a 0. 0, 1, that's a different bit, so we'll put a 1. Then 0, 0, same bit, put a 0. 0, 0, same bit, put a 0. And in the end, this right here equals 4 after we done XOR'd all of these 4s. So that's why this output is 4 over here. Boom. Now, just in case that didn't make sense, y'all, let's take a look at example 2, where this time we have 2 queries. Boom, and it's a little bit easier to understand. Or I'm not gonna say it's easier to understand, but just in case you didn't understand the first time, hopefully this will help it make sense. So same thing, I'm gonna just copy and paste this over here as we go through it, because now we have 2 queries. So I'm gonna show you how that works as well. Boom. So let's come right here. Let's start our empty array. We're gonna start with the empty array. Now let's go through it. So same principles apply. First thing we're gonna do is we're gonna set IDX to LI, right? So this, in this case, LI index 0 is 1. So we're gonna set IDX to index 1, which would be this 3. Boom. Then after that, so then it says while the index is less than or equal to R of I. So in this case, R of I is 4. So that's our range, index 1 to index 4. Boom. Make sure that's index 4. 0, 1, 2, 3, 4. Boom. Okay, so yeah, this is our range right here. These are the numbers that we're looking at right here. Boom. Index from index 1 to index 4. That's what LI and RI get us. Boom. Then, so now that we know our range, this is our range. Now we need to start performing these operations while we're still in range. So for this, first thing we're going to do is we're starting at 3. So we're going to take the 3 and multiply it by V of I. So in this case, V of I would be 3. Boom. So 3 times 3 would be 9. So first we'll put the 2 here because that's out of the range. Then we do 3 times 3. That's going to give us 9. Boom. Then after that, we're going to set IDX index plus equals KI. In this example, KI is 2. So we're going to move, instead of before we only incremented by 1. This time we're going to increment by 2. So we're going to go from index 1 to index 3. Boom. Then when we get to index 3, now we're going to perform the same operation. Boom. So index 3, which is 5, times this 3, that's going to give us 15. We could keep the 1 here because we jumped over it. Then this 5 is going to become 15. Boom. Then we could stop here because we would have to increment, so we could put the 4. We would have to increment by 2, right? But we're right here at index 3. If we increment by 2, we'd be out of bounds. And remember, we're staying in range. So after incrementing, we'd be out of range, so we could stop right there. But, however, that is just the first query. So let's come down here. Boom. That's just the first query, right? So it says the first query, 1, 4, 2, 3, multiplies the elements at indices 1 and 3 by 3, transforming the array to 2, 9, 1, 15, 4. Let's make sure we have that. 2, 9, 1, 15, 4. Boom. Now we're going to do this second query. Remember, we have 2 queries. So this second query applies to this new input array, or this new array right here. So, but we're going to do the same thing. So let's come back up here while we look at the requirements. So first thing we're going to do is we're going to set the index to Li. In this case, Li is 0, so we're going to start from index 0. Boom, we're going to start from this 2. Then Ri is 2, so index 0 to index 2. So this is our new range right here. This is the range. Boom. So then it says while index is less than R of I, so right now we're still at index 0. Boom, so we need to multiply 2 by V of I, which is 2, so we need to multiply 2 by 2. This should be 4. Boom. Then, once again, we're going to increment the index by Ki. In this case, Ki is 1, so we're just going to increment by 1. So now we're 9. 9, then we repeat or keep going through the while loop. 9 times Vi, once again, 2. 9 times 2 is going to give us 18. Boom. Then once again, we're going to increment the index by K of I, which is 1. So now we're right here at index 2. Boom, right here. Then index 2, 1 times 2 equals 2. Boom. And now we're out of range, because remember, that was our range. Just from 0 to 2 was our range. Index 0 to index 2 is our range. This should be our final answer. Let's look at example 2, make sure it matches, right? It says, or not the final answer, but the final after the query, second query. So the second query, 0, 2, 1, 2, multiplies the elements at indices 0, 1, and 2 by 2, resulting in 4, 18, 2, 15, 4. And is that what we have? 4, 18, 2, 15, 4. Boom. Yep, that's it. But we're not done yet, because remember, now we have to XOR all of the elements in this array. So let me go ahead and get you those elements, or the binary representation. So for 4, we'll have 0, 1, 0, 0. That equals 4. Then for 18, we are going to have 1, 0, 0, 1, 0. That equals 18. Boom. Then for 2 is 0, 0, 1, 0. That equals 2. Then 15 is equal to 1, 1, 1, 1. That equals 15. And then last but not least, 4 is 0, 1, 0, 1, 0, 0. Boom. Now let me just make sure these are the correct numbers. They should be. Okay, boom. Now, let me see, clean this up. Need some leading zeros so it could match with the 18. Boom. Boom. Okay, and yeah, this is 4. So now we need to XOR all of these. So first we're going to XOR 4 and 18. So we'll do that down. Or I guess we do it right here. Boom. First we're going to do 4 and 18. So let's come do this. Boom. So once again, different bits equals 1, same bits equals 0. Just clean this up. Boom. So we can see. All right, so 0, 1, different bit. So we're going to come underneath this and we'll put a 1. Boom. Hold on. 0, 0, same bit, put a 0. 1, 0, different bits, put a 1. 0, 1, different bits, put a 1. 0, 0, same bits, put a 0. Boom. Now let's go ahead and move this 2 up. And let's compare these. Boom. Hold on. So let's do it now. 1, 0, different bits, put a 1. 0, 0, same bit, put a 0. 1, 0, different bits. Boom. 1, 1, same bit. 0, 0, same bit. Boom. So let me just check this. Make sure we good. Okay, boom. Now it is time for 15. So let's bring 15 on up. Boom. So now, hold on. Boom. So different bits is going to be, 1. So different bits is 1, 0 is different, we put a 1, 0, 1 different, put a 1, 1, 1 the same, put a 0, 0, 1 different, put a 1, 0, 1 different, put a 1, boom, and finally, let's bring this 4 on up, and we can compare these two. And let's see, 1, 0, different bits, put a 1, 1, 0, put a 1, 0, 1, put a 1, 1, 0, put a 1, 1, 0, put a 1, and in the end, I believe that should equal 31, y'all. Let me go ahead, give me a minute, y'all. But yeah, in the end, that's 31. And that is our output, y'all. Boom, y'all. So that's how the question works. That's how the XOR works. I hope that makes sense to y'all. And now that we understand the question, let's get into the fun part, the actual solution, y'all. The solution is a little bit more difficult than yesterday because the constraints are a little bit different, but we should be able to get through it. So let's go ahead and get through it. So first, we need to get the total number of elements. So we're going to say let n equal nums.count. Boom. Then we need to handle the modulo value. So we'll just say let mod equal 1 underscore 000 underscore 000 underscore 007. Boom. Now we're going to convert the input array to N64 for safe multiplication. So we're going to declare a variable called R, set that equal to nums.map. Open under brackets, we're going to say int 64 parentheses $0. Boom. Now we're going to create a dictionary to store lazy multiplicative updates. The key is going to be the index. The value is going to be the multiplier effect starting at that index. So we're going to come underneath this, declare a variable, we'll call it delta, colon, square bracket int, colon, int, come outside of that, and we initialize it with a blank dictionary. And sorry, y'all, this should be, the value should actually be, not the key, but the value should actually be int64. Boom. Now we're going to create a helper function for fast exponentiation, and it's going to be used to compute the base time or to the power of the exponent, and it's going to then mod efficiently, and that's going to help with big O of log x. So we'll come right here and we'll declare a function called mod pal, open up the parentheses, underscore base, colon, that's going to be int 64, comma, underscore exp, colon, that's going to be int 64, comma, underscore mod, colon, that's going to be int 64. Then it's going to return, you guessed it, int 64, and we'll open up the brackets. Then we're going to declare a variable called result, colon, int 64, set that equal to 1. Boom. Declare a variable called base, set that equal to base mod, and then we're going to declare a variable called exp and set that equal to exp. Hold on. Boom. Now we're going to, for standard binary exponentiation loop, we're going to come underneath this and we'll say while exp is less than 0, or greater than, while exp is greater than 0, then we're going to open up the brackets. And if the current bit of exponent is 1, we're going to multiply the result. So we'll say if exp bitwise and 1 and sign, equals 1, then we'll open up the brackets and we're going to say result equals, open up the parentheses, result times base, come outside of that, and we're going to say mod. Boom. Then we're going to come underneath this, and we're going to say base equals, open up the parentheses, base times base, come outside of that, we're going to say mod. Boom. Then we're going to shift the exponent right, meaning we're going to divide by 2 by saying exp greater than equals 1. Boom. Then we could come underneath this while and we'll say return result. Boom. But we're not done yet because we still need to process each query. So we'll come underneath this and we're going to say for Q in queries. We're going to open up the brackets and we're going to say let L equal Q square bracket 0. This is where we're going to set these, right? The Li, Ri, Ki, and Vi. So remember what I was saying. L is index 0. R, we're going to set that equal to Q square bracket 1, which is index 1. Sorry, y'all. Comma. Then we're going to set K equal to Q square bracket 2, which is index 2. And then finally, we're going to set V equal to Q square bracket 3, which would be index 3. Boom. Now, if the multiplier is 1, it has no effect, so we could skip. So we could come underneath this, and we could say if V equals 1, we can open up the brackets, and we can just say continue. Boom. Now, for case 1, if K is greater than 1, then we're going to sparse updates, and by coming underneath this if, and we're going to say if K is greater than 1, we're going to open up the brackets and we're going to declare a variable called I. We'll set that equal to L. Boom. Then we're going to apply multiplication directly at every kth index. So we'll say while I is less than or equal to R, we'll open up the brackets and we'll say R square bracket I, set that equal to, open up the parentheses, R square bracket I, come outside the square bracket, still inside the parentheses, times int 64, open up the parentheses and pass in V. Come outside both those parentheses, we're going to say mod int 64, open up the parentheses and pass in mod, capital case mod from up here, not this mod from this helper function, this mod with the capital case. Boom. Then we're going to come right here and we're going to say else, which would be our case 2. If K is equal to 1 or in the contiguous range, we're going to use lazy propagation. So we're going to say let val equal int 64, open up the parentheses, pass in V. Come underneath that, we're going to mark the start of the range with multiplication. So we'll say delta square bracket L. Come outside of that, we're going to set that equal to, open up the parentheses, open up some more parentheses, and we'll say delta square bracket L. Come outside of the square bracket, we're going to say question mark 1. Come outside of those parentheses, we're going to say times val. Come outside of that, and we're going to say mod int 64, open up the parentheses, and once again pass in the capital case mod. Now we need to compute modular inverse of val using Fermat's little theorem. So we'll come underneath this and we'll say let INV equal mod pal, open up the parentheses, val, comma, int 64, open up the parentheses, mod, sorry, this should be the capital mod minus 2, come outside of the parentheses, we're going to say comma, int 64, open up the parentheses, pass in mod again, boom, boom. Hold on though. This should be in. Hold on. This should be 2 sets. We need to close these parentheses. So hold on. Boom. So it should be 2 parentheses right here because we still need to close this one. Boom. Then we need to mark the end of the range to cancel. So we'll come underneath this and we'll say delta square bracket R plus 1, come outside of that, set that equal to, open up the parentheses, two parentheses. Then we're going to say delta square bracket R plus 1. Come outside the square bracket, question mark, 1. Come outside the parentheses, times INV. Come outside those parentheses, we're going to say mod int64. Open up more parentheses, pass in mod again. Boom. And now we need to apply all lazy updates using prefix multiplication. So we're going to come right here. We're going to declare a variable called cur, colon. That's going to be an integer, int64. And we're going to set that equal to 1. Boom. We're almost there, y'all. Almost there. We got 2 more for loops. Boom. So we're going to say for I in 0 dot dot less than n, we're going to open up the brackets, and if there's a delta event at this index, we'll apply it. So we'll say if let d equals delta square bracket I, come outside the square brackets, open up the brackets, and we'll say cur equals, open up the parentheses, cur times d, come outside of that, and we're going to say mod int 64, open up the parentheses, pass in mod. Boom. Now we're going to apply the accumulated multiplier to the current element. So we'll come underneath this if, start another if. We're going to say if cur does not equal 1, we'll open up the brackets and we'll say r square bracket I, come outside of that, set that equal to, open up the parentheses, r square bracket I times cur, come outside the parentheses, and we're going to say mod int 64, open up the parentheses, mod. Boom. Now we need to compute the XOR of all final values by coming underneath this. We'll declare a variable called result, colon, that's going to be int 64, set that equal to 0. Then we're going to say for v and r, open up the parentheses, we're going to say result. Then we're going to use this up caret equals v, come underneath this, and we are going to say return and open up the parentheses and pass in results, y'all. Boom, that should be all she wrote. Let's go ahead and give this a run. I know it was a lot, y'all. Let's see if we can get it to run. First try would be great. Oh, so time limit exceeded is a crazy error to get because now I gotta find where the error is. At least with the wrong answer, you know where you went wrong. This time limit exceeded. Let's see if we can figure out where we went wrong, y'all. Give me a second. Oh, maybe this is it right here. We need to increment I by saying I plus equals k. Boom, let's see if that did the trick, y'all. Hopefully it did. It's accepted, y'all. That's what I'm talking about. So let's go ahead and submit it. Make sure it's still accepted after we submit it. Let's see, and look at that, y'all. 1,549 milliseconds beats 100% of users. That's what I'm talking about. That's what I like to see, y'all. So, with that being said, before we go, make sure you get one more look at the code. This is the top part. This is the middle, or the top of the middle. This is the bottom of the middle. And this is the bottom of the code, y'all. And then with that being said, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.